All right, we're almost done here. We got two more lessons. This one is on what's called an annuity, and it's broken into two parts. The first one's future value. What is this going to be worth in the future? And we're going to look at this next lesson, present value. What would it be? What is it worth now? So there's two different formulas, and before we get into it, let's talk about what an annuity is. An annuity is really common. You notice with simple and compound interest, it was a one-time payment every time, right? You put the money in the bank, and then you didn't touch it, right? So you deposit $10,000, and then after 5 years, you'd get it out. Or with simple interest, same thing with simple and compound, it doesn't matter. Or maybe you'd borrow money for 10 years, and then at the end of 10 years, you'd pay it back, right? Well, annuities are the more common and realistic thing that happens, which not to say those other ones don't. They do exist, and they are used for lots of things. But let's say you're making a car payment, right? An annuity is like your car payment. It's a series of payments or investments, because you could be investing money, it's the same. But we'll think about the car payment for now, right? Made at regular intervals. So maybe you take out a car payment, right? You take out a loan and it's a $30,000 car. Man, oh, cars are expensive, right? Well, you start paying that off in, first month, second month, third month. You keep paying money, right? That's what an annuity is. You pay it off. So that car loan, you're going to have to pay them interest, but every time you make a payment, the interest goes down by a little bit. Same thing, what if you're saving up for school and every month, let's say you need to save $30,000 for school, and every month or every week you put money in, right? Whatever that interval is, month, week, day, year, right? Every couple months. So every month, let's say you put money in the bank, right? To try to get up to that amount. So now you're earning interest. So the idea is, remember, it doesn't matter whether you're borrowing or you're the person lending the money, right? It's the same formula. So what you're either paying money because you've borrowed from the bank, or you're investing money because you're putting money into the bank, right? It's the same thing, okay? So that's what an annuity is. It's basically, and that's the key, remember, it's a series of payments made at regular intervals. So maybe that interval is like weekly, or maybe right now I'm making a car payment and I do a weekly car payment, right? I literally, every week I make a car payment of whatever, it's $156 or something, you know what I mean, to pay off a vehicle, right? All right, so I have a weekly annuity, right? That's my regular interval, and I pay it off till it's done, okay? Or it could be monthly or yearly or et cetera, right? Okay, now, you're going to see a couple terms pop up. The good news is you don't have to worry too much about them. All the annuities we work with are going to be simple annuities and ordinary annuities. So what does that mean? Again, if you see something that says it's an ordinary simple annuity, don't worry, they all are. You can get into some real complex math, and those of you going to finance will get a little more deep into it. But most annuities that you work with, and your mortgage, your house payment, same with that. There's another annuity. I have a mortgage, right? I'm paying off a house. Okay, that's another annuity. So what it says is when you make the payment or invest the money, it coincides. It happens at the same time the interest gets added in, right? So they add the interest in every month, and you make a payment every month, right? That's what simple means. And ordinary means the payments are made at the end, not the start of each interval. So in other words, at the end of each month. So at the end of a month one, you make a payment and you get your interest, okay? So don't worry, everything we will do is simple and ordinary, okay? So just keep that in mind. All right, so here's the formula down here. Let me move it up so we can look at it a little better here. So now, first thing, I want to change this. Your textbook, I forget what letter it uses, but most of the ones I've used just use FV for future value. And we'll use that to make it clear instead of A. Okay, you can make it A. Remember, A is the amount. So when they say A, if you see it in the textbook and they say A for amount, right, we're talking about the future amount. So I want to use F, or FA or FV, okay? Future amount. R is your regular payment. So how much are you putting in the bank or borrowing? If you get a car loan, they'll say, okay, this is how much you have to pay us every week or every month or whatever, okay? So that's the regular payment. Or if you're investing, right, how much are you putting in the bank every week or month? Now, next thing, the I is our interest rate divided by the number of compounding periods. So that should sound familiar. We saw that with compound interest, right? Because annuity uses compound interest, okay? So remember, it's interest rate divided by the number of compounding periods, and it's generally, I'm going to add in here per year, okay? Because that's pretty much everything is done annually per year. Okay, and the last thing here, the N, is the number of periods that we're going to have to put that interest in, okay? So the number of compounding periods. So how do we generally get that? It's usually the number of years, right? So let's say I do a car loan right now. I'm doing one for 3 years, right? So I 3 years, and if I'm paying monthly, I'm going to go 3 times 12, right? Although I'm doing weekly, so it's going to be, 3 times 52, right? That's how many payments I have to make. So this is generally the number of years times the number of compounding periods per year. So like I was saying about my car, right? Right now, I bought a car a couple years ago. So basically I figure out, I could figure out, and I did this, I figured out how much it's supposed to be, make sure it actually matched up with what the people were telling me. Like, you can do this. I do this with my home. I've done it with, like, things like that when I want to know how much is this loan going to cost me. I actually use this in university when I was figuring out loans, these formulas, okay? So you can use them to really get an approximate idea of how much something's going to cost by using the interest rate and whatnot. And it'll say when you look these things up in the bank or the car dealership, how much, how many months, how many, so on and so forth. So like right now, my number of years, I did a car for 3 years times 52, right? So what is that? 156 payments, right? That's how many payments I'd have to make, right? But then they take that interest rate, don't forget, and you have to divide it by the number of compounding periods per year. So you take that and you divide it by 52 or however many payments you're making in a year. All right, so let's just check out some examples. I'm already rambling too much. All right, so when you do these, make a little tally, a little list, along the side of what all your variables are going to represent. So future value, the regular payment R, the interest rate, and the number of payments, right? All right, so now you invest $700 every 3 months at 6.4% compounded quarterly. How much did you have in 10 years, or how much will you have? So this is a future value, right? How much will I have in 10 years? That's telling me the future. So that's what we're looking for. All right, now what do we know for sure? Well, we know we're going to invest $700. That's our regular payment, right? So the R is going to be 700. Now, every 3 months, okay, compounded quarterly. Every 3 months, compounded quarterly. These should always match, because remember we said our annuity is simple and ordinary. So the simple part, meaning that these will always match up, right? Compounded quarterly means 4 times per year, right? So if I'm paying every 3 months, well, that's 4 times per year, right? 3 plus 3 plus 3 plus 3, that's 12 months, right? So these will always match up. If I'm paying every 3 months, that means quarterly, okay? So what we have to do is we have to take our interest rate, which is 6.4%, so we make it 0.064, and we need to divide that by 4, because we're breaking it up quarterly into 4 payments in the year, right? Every 3 months. So 0.016. And the number of payments we're going to have to make, well, we're going to do this for 10 years. We're going to invest for 10 years, and we're going to 4 times a year put $700 in, right? So maybe you have some money coming to you, or maybe you just want to save up, and then every 4 years you're going to put money into this annuity, right? Or sorry, every 4 months, right? Or 3 months. Every 3 months, which is quarterly. Man, I'm mixing stuff up. All right, so that would mean we're going to make 40 payments. Now, before we even use the formula, we can answer a question. There's always a question that comes up. The question is, how much did I actually invest? Right? How much did you invest? So what do I mean by that? Like, without figuring out the interest you earn, just how much did you invest? Well, we made 40 payments, right? We did it 40 times for 10 years, 4 times a year. We invested $700. So what's 40 times 700, right? So we can calculate that easy. That's not anything special. We don't need a special formula. We've invested $28,000 so far, right? Now, the annuity part, and that formula is going to tell us how much the interest we make is plus the $28,000, okay? So here's the formula, right? Let me just write it out. Future value is R, your regular payment, big bracket, oof. All right, inside we got a fraction. So there's a lot of calculator work here, right? 1 plus the interest rate to the power of n. Then you got to subtract 1 from it, divide it by I. I won't bore you with the whole how's this formula made. There's a whole section in your textbook if you want to read it. We'll just get to actually doing the calculations here. All right, so my future value is going to be $700. That's my regular payment times 1 plus that interest rate divided by 4, which is 0.016 to the power of 40 payments. And then we have to subtract the 1 off. And then we divide it by that interest rate again, okay? And then we times it by 700. So I won't bore you with me pushing calculator buttons. I'm sure you can handle this. Let's just review the order of things. 1 plus 0.016 to the power of 40, then subtract 1, then divide it by 0.016, and then times it by 700, okay? So try that out in your calculator. See if you get the same as me. I got the total value in the future is going to be worth $38,801.77. So now, if we want to know how much interest there is, right? So let's just kind of summarize. What do we got here? We have, this is our amount of money we actually put in. This is what it was really worth at the end. So if I want to know the interest, because that comes up a lot, right? I can subtract these two numbers, right? Let's take our future value and subtract the amount, right? So what's 38,000? That's how much we actually got from the bank. Subtract the 28,000 that we put into the bank. And when you subtract that, you end up with $10,801.77 in interest. Okay? So keep that in mind, because if a question says how much interest was earned or how much did they, right, there's really three things we can find here. We can find how much did they put in the bank. We can find out how much did they make altogether, right? And then we can find out how much of that was interest, right, by subtracting the two. All right, let's check out a couple more here. All right, so you invest $1,000 every 6 months. I'm working on getting all this down the side here while I talk. Sorry, I do have a loud keyboard. Several of you have pointed that out. It's kind of a fancy one. My brother gave it to me as a gift, but boy, does it click. But I kind of like that. It's like an old school typewriter. All right, so you invest $1,000. All right, so we're going to invest $1,000 every 6 months at 3.5% interest, compounded semi-annually. How much will you have in 5 years? Again, this is the future, right? How much am I going to have in the future? Not now. So we're looking for the future amount, okay? Now, again, 6 months. Every 6 months, compounded semi-annually. Semi-annually means 2 times per year. 6 months happens twice per year. So in other words, it's 2 times per year, right? So remember how those two will always match up, okay? Like I said at the start, okay? All right, so what do we got to do? Well, our regular payment, we're going to invest $1,000, right? Now, this could easily be the same way if we flipped it around and said I'm borrowing $1,000 for 6 months. You know, how much do I owe the bank in the future, right? But generally, people use this to invest money. All right, so the interest rate, 0.035, right? 3.5%. Divided by 2, because we're going to invest twice a year. So we're going to save up all our money in our piggy bank, and then we're going to go twice a year to the bank and deposit into our annuity, okay? So if I divide that, what are we going to get? 0.0175. All right, we're going to do this for 5 years, right? And we're going to do it twice a year, so that means we're going to make 10 payments. Now, before I even start with the big formula, let's just find out how much did I invest, right? How much did I invest? Well, I invested $1,000. Right? And I did it 10 times, right? Twice a year for 5 years. So in other words, I invested $10,000. Okay, now that doesn't tell me the interest. That's just by taking these two numbers here and multiplying them. What's my regular payment? And I made that regular payment 10 times. Now, this formula here, the future value formula for an annuity, will tell us how much it's going to be worth once it earns interest, right? So again, the formula, the regular interest rate times, big bracket here, there we go. 1 plus I to the power of n minus 1 divided by I. All right, so our future value is going to be $1,000 times 1 plus 0.0175. So start by adding 1 plus 0.0175. Then do that to the power of 10. Then subtract 1 from it. Then divide it by 0.0175. And then finally times that by 1,000. And if you do that, let's see what I calculated. I got approximately $108,025.40. All right, so there's how much we invested. There's how much we made. Obviously, to find the interest that we earned, right? How much money did we earn from investing this, right? We just subtracted 2. So what's 108,2540 minus 10,000? So this gives you an idea, like, again, I'm sure not at your age you're not looking up stuff, but you can look all these rates up on bank websites. And it can be a little confusing at first, but when you dig for them, you can actually figure this out and say, okay, what if I want to start putting some money away, and how much would it be worth in the future? And you can use these exact formulas, okay? This is how I did it literally when I was your age. I started figuring this out myself, right? Especially when I had to start planning for university and figure out, well, how much will it cost to take a loan out? How much will these things work? And there was no computer or no calculator for this. We just had to kind of sit around and figure it out. And one day I realized, oh, I actually learned these formulas, right? All right, let's do one more example. I actually remember sitting at the end of high school with a friend, and I was trying to figure out the interest. And I didn't realize, I was like, how am I going to calculate this? And he kind of like looked at me like I'm a dummy. And he's like, we learned these formulas in math class. And I'm like, what? You can use the ones we actually use? And he's like, yeah. It's the same thing. And when I realized, oh, that's all it was, and I just sat there with my calculator and paper and pencil and figured it out and realized, oh, that's actually how much this loan will cost. All right, let's look at one final one here. So let me just write out all my variables here. Future value, R, the regular payment, I, our interest rate divided by the number of compounding periods, and N, our number of years times number of compounding periods. Now, this one's like we want to save right now for a house. So in the future, I want to have $20,000. So this is where it gets a little confusing, right? In the future, I want to have $20,000. Okay, I'm going to save for 5 years. The bank says this is the interest rate. Okay, so like generally when you're buying a house, you want to have a down payment. So, maybe you're graduating school and you start working a job and you want to save up a bit of money, right? So you start saying, okay, well, I want to save $20,000. What's the bank offering right now? If I look up on their website, they'll say for annuities or this or that, here's the interest rate. And okay, I'm going to try and save for 5 years. What I want to know is how much do I need to invest each month? How much do I want to save so that, in 5 years I have $20,000? So how much do I have to put away in the bank each month? All right, so what we're looking for this time is the regular payment. What do I have to save each month? Now the key here is each month and compounded monthly, right? So that means every month I'm going to put some money away. All right, so in the future, we want to have $20,000. All right. Now, what's our interest rate? The bank right now is going to pay us 0.034% interest, and we have to divide that by 12. And I'm just going to leave it like that because I get a pretty ugly decimal. So I'm just going to leave it as, I'll write it down. It's 0.00283 repeating, all right? But probably easier just to leave it as a fraction for now. And we're going to do it for 5 years, and every month, so 12 times, we're going to put some money in the bank, and that means we're going to make 60 payments. So I want to say how much does each of those payments have to be? So let's think about our formula here. Here's our formula. Future value equals the regular payment times 1 plus I to the power of n minus 1 divided by I, right? Well, how do we get R isolated? Why don't we just divide by this entire bracket here, right? If we just divide both sides by this big bracket right here, R would be isolated. So I'm just going to flip this around so that R is, what's your future value? Just divided by this colossal mess. So you just got to be really careful when you're punching everything in your calculator. Take your time. Start learning how to use the save and storage functions on your calculator. Look up how to do it, okay? Like 10 minutes of like looking on YouTube how to do it will make life in math class for the rest of high school and university so much easier. It's worth it. I know it's a pain, but like it's 10 minutes maybe of like learning how to really use your calculator, how to use the saving, storing functions, okay? All right, so here we go. My regular payment's going to be $20,000. Divided by, now here's where we got to be careful, 1 plus I. So I was that decimal number. I'll just write the decimal down here, but normally the first thing I do in my calculator is I'd go, first thing I do is this, what's 0.034 divided by 12, and I'd save it somewhere, okay? So I'd store that number somewhere, and I get this number, right? And I'd store it somewhere. Okay, now I'd add it to 1, right? And then I'd do it to the power of 60, and then I'd subtract 1 from it, and then I'd hit divide, and I would recall the number from storage and divide it by that number I already have saved. Or if you don't have in storage, just divide it by, and then what you do is hit divide, and then just type in 0.034 and put a bracket. Just hit divide, bracket, divided by 12, and then equals, and it'll give you that number again, okay? And then what I do is I go, what's 20,000 divided by that entire number, right? So knowing how to use your answer key and recall key and things like that are really helpful. All right, so we end up getting 20,000 divided by something like 65.3 because there's a lot of decimals, which gives me approximately $306.27. So that means if you save $306.27 a month for 5 years, you will have $20,000 at the end of it, right? At that interest rate. So there you go. That's literally how you can figure it out. So, I mean, you could literally just come up with a scenario right now. If you went on a bank website and just looked up what the interest rates are, which right now they're not great. They're pretty low because of everything that's going on. But if you punch that in, you could literally sit here and figure, okay, I want to have $10,000 in 2 years, or I want to have, $5,000 in 3 years. And here's an interest rate, and I'm going to pay monthly. Monthly is very common. I would pick monthly or weekly, stuff like that. Stick to the basics. And you could figure out how much money you'd have to put away to have that amount of money in the future, right? To plan for your future. So even if it's small, you could set a small goal and use a formula like this to get an idea of how much you should put away a month. So I would suggest try one yourself. Just come up with some numbers and come up with something, see how it works out.